Hello, hi, bro. Welcome to the student brand. Today, we are going to discuss about light refraction. Light refraction, okay? Light reflection and refraction. But especially in this class, I'll discuss about light refraction. I hope in the previous video, if you see the live class, I explained light reflection chapter. Now I will explain about light refraction. So what is refraction? Refraction is nothing but the path of the light changes when it is moving from one medium to another medium. Suppose one medium I am considering the rarer medium, another medium we are considering the denser medium. The speed of light is more in the rarer medium and the speed of light is less in the medium is called denser medium. Example, air and water and glass, like that we can consider the examples. So here reflection of light is different. When light instant on the reflecting surface, one side is reflecting, other side is coated. Well, it reflect back. But whereas come to the refraction, here light ray passes through the medium, or the medium which allows the light ray to pass through it. That is called transparent medium. So transparent, translucent, and opaque. So three types of mediums are there. Transparent, completely to allow the light to pass through it. Translucent, partially to pass through it. And coming to opaque object, it does not allow the light to pass through it. Now we are considering the transparent. Okay, so in this class we are talking about transparent means so the medium which allows the light completely to pass through it. Okay, so that is a transparent medium. Transparent medium. So here one thing, when it is moving from one medium to another medium, okay, one medium to another medium, like air to water, water to glass, or glass to or some other, like that. Okay, one medium to another medium. So one medium must be rarer, another medium must be denser. If it is same medium, sir, what happens if it is same medium? So if it is same medium means light will not changes its path, or it will not bend. It changes the direction. It does not changes the direction when it is moving in the same medium. Suppose that property is called rectangular propagation of light. Like best example, you can take the air. In air, light ray will move in a straight line path. Light ray will move in a straight line path. Light ray will move in a straight line path. And the refractive index is same for the mediums. If you take one medium, another medium, the refractive index of two medium is same. So then automatically light ray will move in a straight line path. What is the refractive index? So why it is moving like that? Everything we will discuss one by one. Okay. So like it is introduction part. That's why I'm explaining one by one. First of all, we'll discuss right from refraction and how it bends when it is moving from rarer to denser, when it is moving from denser to rarer, how it changes its path. We will discuss all those points. Okay, so now you can see here, I am taking this is one medium. Okay, this is one medium considering. So this is a rarer medium and denser medium. Rarer medium and denser medium. Rarer and denser. Okay. So light ray is moving from rarer to denser. So if it is moving from rarer to denser like this, rarer to denser like this. Okay. So I am taking this the normal line. Normal line. So light ray is moving from rarer to denser. It bends towards the normal line, or it changes the direction, or it moves towards the normal line. The path of the light changes when it is moving from one medium to another medium. The path of the light changes when it is moving from one medium to another medium. So suppose you are taking the rarer medium, denser medium, rarer. Here example, if I take example A, and here water I'm taking, water, and water and glass also we can take, water and glass, like we can take different mediums. Okay. Now, if it is moving from denser to rarer, if it is moving from denser to rarer like this, so if it is moving from denser to rarer, it moves away from the normal line. So in this case, the angle between incident ray and normal line is called angle of incidence. Angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. And here also angle of incidence and angle of refraction. In this case, angle of incidence is greater than the angle of refraction, because the light ray is bending towards a normal line, or moving, shifting towards a normal line when it is moving from rarer to denser. So if it is moving from denser to rarer, it is moving away from the normal line. In the second case, angle of refraction is greater than the angle of incidence. So if I am taking this case 1 and case 2, in case 1, angle of incident is greater than the angle of refraction, because light ray is okay, so here light ray is bending towards the normal line. Okay, so that's why angle of refraction is less than angle of incidence. Here in this case, angle of incidence is greater than the angle of refraction. So it is moving, right? So sorry, angle of refraction is greater than the angle of incidence, because it is moving away from the normal line. Angle of refraction is greater than the angle of incidence. Angle of refraction is greater than the angle of incidence. Okay, so there's a point, case 1 and case 2. That's enough. And one more thing, here, loss of refraction. So angle of we discussed about refraction. Now we will discuss about loss of refraction. Loss of refraction. So what is the loss of refraction? Loss of refraction. What are those? Refraction. Loss of refraction means, so angle of incident is equal to angle of incident is equal to angle of reflection. Incident ray reflected and normal lies on the same plane. So same like this also. So incident ray refracted ray normal lies on the same plane. Incident ray refracted ray normal line. Incident ray refracted ray normal lies on the same plane. Incident ray refracted ray normal line. Incident ray refracted ray normal lies on the same plane. And second one is the ratio of sine of angle of incident to sine of angle of refraction equal to constant. Ratio of sine of angle of incident to sine of angle of refraction equal to constant. That is nothing but refractive index. Sin I by sin r equal to n. Sin I by sin r equal to n. So that is nothing but refractive index. The ratio of sine of angle of incident to sine of angle of refraction equal to constant. So this is about loss of refraction. Once again, listen here. Refraction. What is a refraction? When light ray is moving from rarer to denser, it bends towards the normal line. If it is moving from denser to rarer, it moves away from the normal line. So the bending of the light, the interference of the two media is called refraction of light, or the path of the light changes when it is moving from rarer to denser. Rarer to denser. So that is nothing but refraction. And coming to loss of refraction, incident ray refracted ray normal line. Incident ray refracted ray normal line lies on the same plane. Incident ray refracted ray normal line lies on the same plane. Point number 1. Point number 2, sine of angle of incident to sine of angle of refraction equal to constant. That is nothing but refractive index. Constant, that is nothing but refractive index. I hope it is very clear to you. I hope so. This is about refraction and loss of refraction. And now we will discuss about critical angle and total internal reflection. Critical angle and total internal reflection. So we will discuss two more points related to refractive index. So here we got the name, that is refractive index. So what is the refractive index? What is the relative refractive index? What is the absolute refractive index? We'll discuss now. So refractive index. Refractive index is nothing but So the ratio of sine of angle of incident to sine of angle of refraction. So that we got that. Now here n equal to speed of light in vacuum by speed of light in medium. So c is nothing but 3 into 10 power 8 meter per second. 3 into 10 power 8 meter per second. So that is nothing but speed of light in vacuum. Speed of light in vacuum, c equal to 3 into 10 power 8 meter per second. So speed and refractive index is nothing but c by v. C by v. Okay, c equal to 3 into 10 power 8 meter per second. So this is absolute refractive index. Absolute refractive index. Okay, so with the comparison of speed of light in vacuum by speed of light in medium, that is called absolute refractive index. Okay, so this is absolute refractive index. Absolute refractive index. Refractive index. Absolute refractive index. Coming to relative refractive index. Relative refractive index. What is the relative refractive index? So speed of light in vacuum. So speed of light in medium 1 by speed of light in medium 2. That is nothing but n1 by n2. So actually inversely proportional. So here you will get 2 by 1. 2 by 1. How? Here n is inversely proportional to velocity. So from here itself we can get to know that is n equal to c by v. N equal to c by v, absolute refractive index. Absolute refractive index. Okay. And coming to relative refractive index is nothing but, so speed of light in medium 2 with respect to medium 1, that is nothing but n12 if you are taking. Okay, or if your light ray is passing from medium 1 to medium 2. Medium 1 to medium 2. Okay, so as I said, air is a rarer medium. And water is the denser medium. Air is the rarer medium, water is the denser medium. So light ray is moving from medium 1 to medium 2. Okay, so refractive index of medium 1 with respect to medium 2. So light ray is moving like that. So n12 if you are taking, so velocities, if you are taking velocity will become inversely proportional. So n is inversely proportional to velocity. N is inversely proportional to velocity. N is inversely proportional to velocity. N equal to c by v. C is absolute refractive index. That is nothing but C is the velocity of light in vacuum. That is c equal to 3 into 10 power 8 meter per second. Absolute refractive index is equal to n equal to c by v. Coming to relative refractive index, n12 equal to v2 by v1 equal to n1 by n2. So if you are taking n21, that is nothing but n2 by n1 is equal to v1 by v2. So here you can observe, so whichever the medium comes first, that you have to write in the numerator. Next one you should write in the denominator. So if you write refractive index, automatically velocity is inversely proportional, n2 by n1 equal to v1 by v2. So you have to observe carefully. Okay, so it will be inversely proportional, n2 by n1 equal to v1 by v2. The same thing here will come. So n1 by n2 equal to v2 by v1. So absolute means, so refractive index of absolute refractive index is equal to speed of light in vacuum by speed of light in medium. Any medium we can, other than air or vacuum. Other than air or vacuum you have to consider. Okay, understood or not? So just check once. So C is speed of light in vacuum, that is 3 into 10 power 8 meter per second. So V is velocity of light in any other medium, like we can take water and any substance you can consider. But here, so C is absolutely, it must be air or vacuum. So same value will come, that is 3 into 10 power 8 meter per second. So V different medium we can consider that. That's why we can take that is absolute refractive index. With the comparison of air or vacuum we are taking, that's why absolute. So if you are taking with different mediums, like we can take water and glass, and like a glass and some other material, like that if you consider with the different mediums if you take, then it will be relative refractive index. So very, very important. Okay, so notations definitely they will ask. At the same time, based on this one, problems also they will ask. Very, very important concept. At the same time, 2 marks question will come. Even 1 mark also can be expected in MCQs. So that much important this concept. That is the refractive index. And Snell's law also they will ask. Snell's law is nothing but laws of refraction. incident ray, refracted ray, normal line lies on the same plane, and the ratio of sine of angle of incident to sine of angle of refraction equal to constant. That is nothing but refractive index. So absolute refractive index and relative refractive index. So C is here 3 into 10 power 8 meter per second. So velocity of light in vacuum or 8. Okay. So that's enough. That is about refractive index. And coming to the next one, next topic is the critical angle and total internal reflection. Critical angle and total internal reflection. Okay. So now you can observe here. Critical angle and total internal reflection. So I'm taking like this. So this is the rarer medium and denser medium, rarer medium and denser medium. Normally what happens if the light ray is moving from denser to rarer, it moves away from the normal line. Normally what happens? If the light ray is moving from denser to rarer, it moves away from the normal. So I'm taking like this, the light ray is moving from denser to rarer, so it is moving away from the normal like this. So angle of incidence and angle of refraction. Okay, done. So it's clear. So like this I'm taking from here, because remaining also we have to take. Okay, so I'm taking here. So here you can observe and keep on sending the light ray. So here from here, so it moves away. Again you are sending, so it moves away. Again you are sending. So you are changing the angle between incident ray and normal line. Angle between incident ray and normal line. So you keep on changing the angle. At certain angle, the light ray moves along the normal line or gauges or passes. So refracted ray passes or gauges along the normal line. Once again I will explain, listen carefully. Once again I will explain, so listen carefully. Okay, so here, so I am taking this rarer medium and denser medium like this. Okay, so normally what happens if the light ray is moving from denser to, it moves away from the normal line. Light ray is moving from denser to rarer, it moves away from the normal line. Okay, so it's moving like this, keep on moving like this, and here also moving like this. So at certain angle of incidence, so the refracted ray passes or gauges or moves along the surface. Once again, listen carefully, observe carefully, so properly you can observe. When the light ray is moving from denser to rarer, what happens? So it should move away from the normal line. But here, at certain angle of incidence, so you keep on changing the angle. At certain angle, so the light ray, so the refracted ray passes or gauges or moves along the surface. That angle is called critical angle. Once again, observe carefully here. So I'm taking like this. So you can observe. So I'm taking like this. Light ray is passing along the normal line, along the surface. So this is the 90 degrees. So it makes 90 degrees with the normal line. Refracted ray makes 90 degrees normal line with the normal line. So this is the refracted ray. So the definition of critical angle. So the critical angle definition is, so at a certain angle of incidence, the refracted ray passes along the surface or gauges or moves along the surface. That angle is called critical angle. Or simply, if the light ray is moving from denser to rarer, at certain angle of incidence, refracted ray makes 90 degrees with the normal line. So that angle is called critical angle. Sir, what is total internal reflection? Total internal reflection also I will explain. Total internal reflection is nothing but, so I am taking the light ray, same light ray I am considering here. So like this. Okay, from light ray is coming from here. Okay, so what happens? it makes more than 90 degrees. So here 90 degrees, then here theta. It makes more than 90 degrees with a normal line. Okay, then light ray will reflect back into the same medium. Reflect back into the same medium. Once again, normally, so if the light ray is passing from rarer to denser, rarer to denser, it bends towards the normal line. If it is moving from denser to rarer, it moves away from the normal line. So light ray is moving from rarer to denser, it bends towards the normal line. If the light ray is moving from denser to rarer, it moves away from the normal line. Point number 1. So here 1, 2 and 3. So this is the refraction. First part is refraction. Second part is critical angle. And third one is total internal reflection. Total internal reflection. Total internal reflection. Once again, observe here. Refraction means when light ray is moving from denser to rarer, it moves away from the normal line. Point number 1. Point number 2. So if the light ray is moving from denser to rarer, the refracted ray makes 90 degrees with a normal line. At certain angle of incidence, refracted ray makes 90 degrees with a normal line. That angle is called critical angle. So when light ray is moving from denser to rarer, the refracted ray makes more than 90 degrees with a normal line. 90 plus more than 90. Then the light ray will reflect back into the same medium. This phenomenon is called total internal reflection. Total light internally reflection takes place. Total light internally reflection takes place. That's why it is called total internal reflection. Total internal reflection. I hope it is very clear to you, right? Yes. So that's enough. And the next one more. Glass slab we will discuss. So when light ray is passing through the glass slab, so how it changes. And what is lateral displacement and vertical shift. So everything how it will changes, we'll discuss now. So here you can observe, I am taking the glass slab like this. So light ray is passing like this. This is the incident ray. This is the incident ray. So refracted ray, and this one is the normal line. So this is the emergent light ray. So if you are extending the incident ray, so we are extending the incident ray, initial direction of the incident ray, the angle between emergent ray and initial direction of the incident ray is called lateral displacement. Okay, so now you can observe here once again. So incident ray, refracted ray, normal line. Angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. Angle between emergent ray and normal line is called angle of emergence. The distance between emergent ray and extended incident ray, that is called lateral displacement, or initial direction of the incident ray is called lateral shift. And coming to the vertical displacement, so here I am taking the beaker. Okay, so if you place the coin, okay, at the bottom of the coin, so at bottom of the beaker, so I'm placing the coin at the bottom of the beaker. So this is the coin. So I placed at the bottom of the beaker. So you are standing here. You can able to see. Okay, but position 2. So I'm taking the point position A. So you are standing here, position B. So you can't able to see the coin. After pouring water, the coin position rises up. So the position will be raised until here. So this is the apparent position. Apparent position of the coin, or this is the actual position of the coin, or original position of the coin. So the distance between actual position to apparent position of the coin is called vertical shift. So the distance between actual position to apparent position of the coin is called vertical shift. Okay, so here the distance between emergent ray to extended incident ray, or initial direction of the incident ray, is called lateral shift. And here you can observe the distance between original position to apparent position of the coin is called vertical shift. So not only this one, so if you place the pencil also, if you place the pencil, okay, so I'm I'm placing the pencil in the beaker. So water is filled until certain height, and you place the pencil. So you place the pencil, then the pencil here, it appears to be bent here. Okay, so actually the original position here, it appears to be bent. Okay, so because of the refraction only it appears. That is a point number one, point number two. And if you are taking, so this is one. So we'll do activity same. We'll do the same activity. So for coin we play. Okay, so coin I'm taking one, and pencil, and next one is lemon. So if you place the lemon inside of the water, it appears bigger. So if you place the lemon inside of the beaker, okay, so if you place here, it appears bigger, right? So now we will do the same thing. Okay, experiment will do it. So here you can see, suppose I am taking like this a beaker, suppose example. Okay, I hope it is very clear to you all. So is it visible to you? You can check here. So I hope it is visible to you. So I'm placing the coin here now. I'm placing the coin. Okay, so this is the coin. So you can observe, I'm placing the coin. Okay. So I hope it may be visible to you. Like, so one more, we'll take pencil also. We'll take pencil. So you can observe this is a pencil. I'm placing the pencil also here. You can see, as I said, it appears to be bent. Okay, so I can't able to move randomly, but still okay. So here you can see this second one I'm doing, second one. So first one is coin one and second one is pencil I'm placing. So just observe here. So you can see it appears to be bent. Okay, at the point of, okay, the interference between water and air. The interference between water and air. Exactly, maybe it is floating. Oh my god. Not able to. Okay, so you can observe at least. You can observe, right? Understood or not? Yes. I hope it is very clear. Now I'll place lemon. So lemon it appears bigger. So it appears very clear also. Check once here. So I'm placing the lemon. So you can see. So you can observe lemon appears very bigger. So you can see here. Yeah. Okay. So I hope you can understand. So that's enough. Is it clear? So I hope it is very clear. That's enough. So after placing one object, it appears if you place the coin, normally you are taking the beaker and place the coin. Okay. So initially you can't able to see. After pouring water, it appears, right? So the distance between actual position to apparent position of the coin is vertical shift. And coming to the pencil, so if you place the pencil, it appears at the interference between water and air. So water and air at that interference. So the pencil appears to be bent. So here you can observe. Okay, the pencil appears to be bent like this. And if you place lemon also, it appears bigger. It appears bigger. So we can observe the things. So these 3 points we can take. Point number 1, 2, 3. So 3 experiments. And a glass slab, even if you place, okay. So you draw the line on it and place a glass slab over it. Then it appears also like a somewhat bent. That's enough. So due to refraction of light, all these things happens. I hope it is very clear to you. Next, so we'll discuss Spherical lenses. Lenses we'll discuss now. Convex lens and concave lens. Refraction. Refraction, Ankar, thank you. So, refraction of light we'll discuss. Refraction of light. Refraction of light. Then we'll discuss about lenses, right? So we'll start discuss about lenses. We'll see now. I'm taking here spherical lens. Actually, this I'm taking lens. How to draw the lens? Take two dots and join those dots. So 1 and 2. Then you can draw easily lens. Okay, so lens you can draw like this. So I'm taking here like this lens. So light ray is passing. So if the light ray is parallel to the principal axis, light ray is coming from infinity. After refraction, light ray passes through focus, F2. Coming to the second one. So optic center F1 to F1, F2 to F2. So light ray is passing through optic center. Light ray is passing through optic center. No deviation takes place. So it moves in the same direction.
So F1, 2F1, F2, 2F2. So light ray is passing through optic center. So moves in the same direction like this. So without any deviation, light ray moves in the same direction. So these are the ray rules of convex lens and concave lens. Ray rules of concave lens and convex lens. You can check any textbook. If you have any doubts, you can ask. And one more thing, so there is a physics CBSE grade 10 physics notes. You can check in the community post. So you can get the physics notes CBSE grade 10, okay, in detail. So all the chapters: light reflection, refraction, electricity, magnetic effects of electric current, and human and color football. So 4 chapters notes is available along with the problems, electricity problems also, and definitions also. So you can check once. You can check. So in the community post in the YouTube channel. So same. Okay. So definitely you'll get it. Check once. Now we will discuss about image formations of so now image formations by convex lens. So there are 6 image formations. I am taking the convex lens like this. So optic center F1, 2F1 and F2, 2F2. So object is at infinity, image is forming at F2. So how many light rays are required to form the image of the object? Minimum 2 light rays. I am taking one light ray, I am taking like this, another light ray I am taking like this after refraction. So those light rays will meet at F2. Okay. So image will form real and inverted, and size of the image is highly diminished. So point number 1. And coming to the point number 2. Optic center F1, 2F1, F2, 2F2. So I am taking object is placed 2F1. Object is placed beyond 2F1. One light I am taking like this. So it passes through focus. So one light I am taking, it passes through focus. F2. So another light I am taking through optic center. So image will form between F2 and F2. So here like this in between. Okay. So here I am taking like this. So image will form between F2 and F2.
Image will form. So image will form between F2 and 2F2. You can observe here. Object is placed beyond 2F2. Beyond 2F2, image will form between F2 and 2F2. Nature of the image is real and inverted. Size of the image is diminished. Size of the image is diminished. And coming to the next one, third one. Coming to third one. So here I can say like here. So optic center F1, 2F1, F2, 2F2. So object is placed at 2F1. So image also will form at 2F2 itself. Image also will form at 2F2. So F2 and 2F2. Image also will form here. So a light I am taking like this, it passes like this. Another light I am taking through optic center. The image will meet here. Object is placed at 2F1. Image will form at 2F2. Nature of the image is real and inverted. Size of the image is same size. Same size. Okay. Same size of the image will form at 2F2. Okay. I hope it is very clear to you. So check once again. So object is placed at 2F1. Image will form at 2F2. Nature of the image is real and inverted. And size of the image is same size. Next one, fourth one. Fourth one. So optic center F1, 2F1, F2, 2F2. Object is placed at 2F1. Image will form at 2F2. Object is placed at 2F1. Oh, that is completed. No object now. Object is placed between. So F2 and 2F2. Object is placed between 2F1 and F1. One light I am taking like this. So it passes through focus. Another light I am taking through optic center. So the image will form here. So object is placed between 2F1 and F1. Image will form beyond 2F2. Beyond 2F2. Nature of the image is real and inverted. Size of the image is enlarged. Compared to object, image size is increased. Coming to the fifth one. Optic center F1, 2F1, F2, 2F2. So object is placed at F1. One light I am taking like it passes through focus. So the light rays will meet at infinity. F2 and 2F2. F2 and 2F2. So one light I am taking like this passes through focus. So another light ray through optic center. So object is at F1, image will form at infinity. Nature of the image is real and inverted, highly enlarged. Image is highly enlarged. So image will form at infinity. And coming to the sixth one. Sixth one is So 6 1 I am taking here like this. Okay. Optic center F1, 2F1, F2, 2F2. So object is placed between F1 and O. One light ray I am taking like this, it passes through focus. So another light ray I am taking like this. So if you are extending those light rays will meet beyond 2F1. Okay. So image will form here. So object is placed between F1 and O. Image will form same side of the object. Image will form same side of the object. Nature of the image is real and inverted. Sorry, virtual erect and enlarged. Coming to compared to the object, image size is increased. Object is placed between F1 and O. Image will form same side of the object, virtual erect and enlarge. Virtual erect and enlarge. I hope it is very clear to you all. So this is sixth one. Okay. So that's enough. This is about image formation by convex lens. Image formation by convex lens. So we'll discuss about concave lens. Concave lens, only two cases are there. Concave lens, only two cases. Concave lens, only two cases are there. We'll discuss that one. Only two cases. So we'll see. So optic center F1, 2F1, F2, 2F2. Okay, object is placed at infinity. One light ray I am taking like this, another light ray after refraction. Those are moving away from it. Okay, so here you can see. Object is at infinity, image is forming at F1. Nature of the image is virtual erect and diminished. Here, what type of image will form? Virtual erect and highly diminished, because image size is very less compared to the object. So next one. So optic center F1, 2F1, F2, 2F2. So object is placed anywhere between optic center and infinity. One light ray I am taking like this, another light ray passes through optic center. So if you are extending here, the image will form between F1 and O. Okay. Object is placed anywhere between optic center and infinity. Image will form between F1 and O. Nature of the image is virtual erect and diminished. So here highly diminished because point size image is forming. Here just diminished. Okay. So compared to the object, image size is decreased, reduced. That's enough. So this is about object and image of concave lens. Okay. Nature of the image formed by the concave lens. So in concave lens only, always virtual erect and diminished image will form. In concave lens, always virtual erect and diminished image. In convex lens, both images will form. So real and inverted and enlarged and diminished also. Real, virtual erect and enlarged. Virtual erect and enlarged. Real inverted, enlarged and diminished. Okay. So both type of images will form in the convex lens. In concave lens only virtual erect and diminished. And coming to the power of lens. Power of lens is positive for convex lens. Power of lens is negative for concave lens. The reciprocal of focal length. The degree of converging or diverging of lens achieved is known as power of lens. The degree of converging or diverging of lengths achieved is known as power of lengths. Okay, so that is about power of lengths. P equal to 1 by f, or simply we can say reciprocal of focal length. Length formula 1 by f equal to 1 by v minus 1 by u. Magnification equal to m equal to v by u. Okay, so height of the image by height of the object. So this is about lengths. Okay, so if you have any doubts, happy Diwali to all. If you have any doubts, you can let me know. You can ask. So in the community post, go and check in the community post. So there is a notes for grade 10 CBSE physics, light reflection, refraction, human and color fluid, electricity, magnetic effects of electric current. So all those 4 chapters notes is available. You can check in the community post. Okay, so PDF is available. So clear, just check once. If you have any concerns, if you have any doubts related to CBSE Grade-10 physics, you can now reach me through this number. If you have any doubts in any subject like other than physics, remaining subjects, so maths, English, like chemistry, like biology, and for grade 11 and 12 also, so for JEE and NEET, if you need classes, just go reach to me through this number. So there is a team, great team. So nearly 10 plus experienced faculty members are available. Okay, 10 plus experience and 20 years experience also. Okay, more than 5 for the 5 years experience faculty members are available for JEE and NEET student NEET. So you can come and check. Okay, so take the demo classes. Once you go through the demo class, if you need, you can schedule the demo class through this number 984981804. Okay, so you can reach me through that number. So if you have any doubts, you can reach me through that number. So thank you so much for joining and attending, listening my class and giving an opportunity to teach. So this is Evar sir from Student the Brand. So if you like the content, if you like the channel, if you like the explanation, do like, share and subscribe to Student the Brand. Thank you so much.